Number 53 gives us this function, which is actually kind of famous within the world of mathematics. It's called the Witch of Agnesi. We'll draw the graph in a minute. It's got a cool shape. Y is equal to 1 over x squared plus 1. They want us to find the equation of the tangent line, both at x equals positive 1 and at x equals negative 1. So we're really going to have two different answers to this question. But either way, though, guys, we're going to need our derivative. So to take the derivative of y with respect to x, that is going to require, at least with what we know right now, it's going to require the quotient rule. Now, later on in this chapter, I believe in section 3.5, we're going to learn a rule called the chain rule, everybody, which is actually the better way to handle this. So I might come back to a problem like this when we take notes on that. By the end of this chapter, I'm going to say the following. It's kind of a waste of time to use the quotient rule when one of the two sides of your fraction is a constant. But we don't know any other way to do it right now, so the quotient rule will still work, but I think you'll see in just a minute why eventually there might be a better way. Okay, shut up, Fontana. Here we go. Derivative by the quotient rule. The denominator is x squared plus 1 times the derivative of the numerator. Aha. Since the numerator is constant, its derivative is 0, which of course is just going to make that whole term cancel out. But I'll get to that in a minute. So that was bottom times derivative of the top minus the top, 1, times the derivative of the bottom, which looks like it's just going to be a 2x. All over the denominator, x squared plus 1, quantity squared. So what does that do for us? This whole first term now cancels out, and we just end up with, let me just keep going over here, guys. We've got a negative 2x up on the top, and then the x squared plus 1 quantity squared down on the bottom. Guys, it is never worth the time and effort to expand a denominator raised to a power like 2. Never, never, never. Leave it in factored form like that. Nothing cancels right here, so that's as good as we're going to get our derivative. So now, let's use a little notation that I don't think you guys like, but the more we use it, the more comfortable we'll get with it. We're going to take our derivative now, dy dx, and evaluate it both at 1 and at negative 1. So I'll start off with x equals 1, and here we go. That's a negative 2 times 1 all over. That's a 1 squared plus 1 quantity squared down on the bottom. So what does that do for us, guys? A negative 2 in the numerator, and then 1 squared is 1, plus 1 is 2, 2 squared is 4. So we end up with negative 1/2 for the slope of our tangent line here, evaluated at x equals 1. Then, let me go ahead and use kind of a sloppy notation here, guys. This is just kind of a hybrid of Newton and Leibniz notation, but let's go ahead and evaluate y of 1. So we're just putting a 1 into this function right here. 1 squared is 1, plus 1 is 2. We end up with 1/2. So right here, negative 1/2, that's the slope of our tangent because it came from the value of the derivative. And then right here, 1/1/2 is our point of tangency. So here we go, guys. In point slope form, we're going to go with y minus the y coordinate of the point of tangency, which is a 1/2, is equal to our slope, which is negative 1/2, multiplied by x minus the x coordinate of your point of tangency, which is 1. So there's our equation now for our tangent line at x equals 1 in point slope form. Let's go 2 quick steps, and we'll have it in slope intercept. That's going to be a negative 1/2 x plus 1/2. We're going to add 1/2 on both sides and get y equals a negative 1/2 x, and that'll end up being plus 1. So that right there, everybody, is the equation of our tangent line here when x is equal to positive 1. So let me go ahead and just label that real quick. Equation of the tangent line at x equals 1. And like I said, I want to come back and graph this one just a little bit later to see if we've got this right. Okay, but with that in mind, I tell you what, we're going to switch colors right here. And now we're going to do everything we can here, guys, when x is equal to negative 1. So let me try to follow my lead from up above. We're taking our derivative, dy dx, but this time we're evaluating it at x equals negative 1. So back to our derivative right here, guys. That is going to give us, we'll save a little time here. Negative 2 times negative 1 is a positive 2 up in the numerator. But the denominator I don't think is going to change. Negative 1 gets squared to make 1, plus 1 is 2, 2 squared is 4. So now the slope of our tangent here is a positive 1/2. And we still have to evaluate the function now at the point of tangency, which is negative 1. So when I put negative 1 back into the original function right up here, that's not going to change at all either. We're still going to end up with the same y value there of 1/2. So we know the slope of our new tangent line, and we know a point, or I should say our new point of tangency. So now we can go ahead to point slope form. Y minus your y coordinate, which is 1/2, equals your slope, which is positive 1/2, times x minus your x coordinate. X minus negative 1 is going to become an x plus 1. So y minus 1/2 is going to equal, we'll distribute now, a 1/2 x plus 1/2. And now we'll add that 1/2 there again and get y is equal to, this one will be a positive 1/2 x plus 1. So that is the equation now of our second tangent line. And I tell you what, guys, just to prove to you we're on the right track here, I'm going to go ahead and, actually, you know what? Let me do something new right here I haven't done yet. I have got, sorry about that. Okay, I got a new calculator app right here that I haven't used very much. So here's actually the Inspire. No, it doesn't need that. All right, let's see if Mr. Fontana knows how to use this thing or not. So we want to do a new document right here. And I tell you what, let's just go straight to a graph. All right, and let's graph this function that they gave us here, guys. It's a stack fraction with a 1 in the numerator. And then our denominator was x squared plus 1. So we'll hit enter, and there it is, everybody. The Witch of Agnesi looks something like that. What I want you to notice here, everybody, and this is kind of relevant to what we're going to talk about next, this is an even function. Whether you put in a positive x value or its opposite, like for example 3 or negative 3, it doesn't matter. You're going to get the same result out for y. And this graph has symmetry with respect to the y-axis. That's what even functions do. Now, let me go back to the work I did just a second ago. The equation of our two tangent lines right here, guys. Okay, one of them in blue was negative 1/2 x plus 1. The other one in purple, positive 1/2 x plus 1. I'm going to graph those two lines on this same graph, and we're going to find out if we did okay with our tangent lines here. So plus or minus 1/2 x plus 1. All right, so let's go here, and where do I tap now? Uh-oh, I have no idea. There's a button to push somewhere here, guys. Is that it? Maybe that's it. F1 of x. Oh. Let's see. Okay, that gets my keyboard up. That's good. And if I hit enter, here we go, F2 of x. So one of ours was, let's take a look. It was 1/2. We'll put the x at the end of that then. And then it was a plus 1. I probably should have done that one second, but okay. Okay, there's that. And then, like I said, guys, what do I hit? Is it this button? This button? No, no. This button? I think I can get there from here. Okay, got it. And then from there, here it is, guys. We had a negative 1/2, and we'll stick an x at the end of that, and then a plus 1 also. Okay, that's what I wanted to see. So my hope here was, everybody, that we would look at this, and this would satisfy you guys, that the red line and the black line that we came up with are both tangents to the original blue curve at the spots where x is equal to 1 and to negative 1. And it looks like that worked here, guys. I'm trying to see how well I could show this right here. If I did a graph trace and then what, tapped where x was equal to, I can kind of move that point around a little bit, but there should be a way to type that in, and I don't know how to do that on the iPad. Anyway, guys, my point was that if we get it to around the spot where x is equal to negative 1, oh, I'm jumping all over from one curve to the next right here. That's not good. Anyway, that should get us to right about there. Yeah, that red tangent line looks, that red line looks like it's tangent to the blue curve at that spot right there. And if I brought it over to the other side right here, where x is equal to about positive 1, oop, overshot it just a little, there we go. That black line looks like it's tangent to the blue curve there at x equals positive 1. So a little bit messy right there, guys, but I think that kind of supports that the answer we came up with on this one here looks pretty good. So that is how we handle number 53.